Okay, so this is a very quick video. You already have the notes in front of you, so if you want, I'm assuming you're gonna follow along in the notes, and I will just quickly go through there. So a few things you need to know. If a triangle isn't a right triangle, you need to use the following to solve it. So you learned how to solve right triangles, where you found 3 angles and 3 sides. Now you're gonna solve acute and obtuse triangles. So there's 4 cases of triangles that are given. There's 2 triangles where you have one side and 2 angles. These are angle, side angle, or side angle, angle. They look like this. Notice angle, side angle is this one. And this one is side angle, angle, because the side is not in between the 2 angles. The other one is where there's 2 sides and 1 angle that's opposite them. So it's like this. 2 sides and an angle that's opposite from one of the sides. Now these ones you're going to use for law of cosine. So we'll get to those in the, or you just did those actually in the 6-5 notes. So the law of sines, what this is these are proportions. You can either use these 2, or you can use those 2, or you can use those 2. So this is the actual proportion that you're using. So example 1, this was given to you like that, and this is how you actually use the law of sines. You set it up as a proportion, and you find the sides opposite them. So I'm given these 2 angles. I'm going to set them up as the sine of 30. And what side is opposite sine of 30? 5. Good. And then I have sine of 70 equals little over little b, because this is the side opposite it. Now with proportions, you cross multiply. So I would have b times the sine of 30 degrees equals 5 times sine of 70 degrees. How do I get b by itself? Good. I divide. So I would divide by sine 30 degrees. And I'm left with b is equal to 5 times sine 70, all divided by sine 30. Now make sure when you're plugging these into calculators, sometimes you might have 2 sets of parentheses here, but make sure this whole thing's in the bottom, because otherwise, or make sure this is all in the top. You might have 2 sets here, because otherwise you'll get the wrong answer. And you should get approximately 9.4 here. Like I said, these are kind of fast, so that way I can upload them on my website as well. I'm going to try to do that for you. I'll let the sub know. But just a quick overview. Example number 2, you were given this, and it says solve for all missing pieces, 3 angles, 3 sides. So first of all, what do you know about 3 angles? Good, they add up to 180. So that's how I found that here. 180 minus 45, which is 20 plus 25. I guess I should have. And then that's where I got 135 for this angle right here. And then I used the law of sines to set it up. So I had the sine of 20 over a, right here, is equal to the sine of 25 over 80.4, right here. When I cross multiply these, I get 80.4 times the sine of 20. Here, I should do it like this. 80.4 times the sine of 20 is equal to a times the sine of 25, right here. How do I get a by itself? Yes, I divide. These then cancel, and I'm left with this. And once again, be careful plugging it in. When you plug this into a calculator, you should get a is approximately 65.07. And these should be approximate symbols. And then the same thing over here. If I'm solving for this missing side, I now have this angle over this side. Well, I found that angle up here. It was 135. So it's the sine of 135 over b is equal to, and then I could have used either one. I could have done sine of 25 over 80.4, or I could have done sine of 20 over a, which I just found right here. But because this was a given side, I prefer using that one just because if I screwed this number up, then this would be wrong as well. So it's always nice to use the given information. When I cross multiply, I'm left with b times sine 25 equals 80.4 times sine 135. Divide by sine 25, these cancel, and I'm left with this answer. When I plug that in, I should get 134.52. Okay, then there's this whole long spiel that you got in your notes. So this is for triangles that are side-side angle. So they look like this one, where there's an angle across from a side, and it's one side, but there's not an angle. And I might have to split this video into two if I want to upload it, but we'll see. Okay, so with this case, there's three possible outcomes, and you're going to see the possible outcomes right now. There's either one solution, two solutions, or no solution. If the sine of the angle is less than 1, then you have this scenario. You're going to set up two triangles. One triangle with the angle you find and one with a supplement. If it's two solutions, then you're going to add up the angles, and they can add up to 360. Or if it's one solution, it's one solution if you add up the angles and they add to be more. So this is when they add to equal 360, add to be more than 180. So you're going to see right now all the different scenarios. So scenario number 1 is a one solution case. So it says solve triangle ABC where angle A is 45, A is 7 root 2, and B is 7. So I plugged in that information over here. Now first, I would set it up. This is angle B and side B. So it would be the sine of B over 7, because that was the angle on the side. And this is sine 45 over its opposite side, which is 7 root 2. When I cross multiply, I end up with 7 sine 45 from, cross multiply here. I have 7 sine 45 equals 7 root 2 sine B. Now notice this, usually there's a number here, but I want B by itself, but sine is kind of married to this. They go together. So I'm going to divide by 7 root 2 here to get sine B by itself. When I divide by 7 root 2 on both sides, I get sine B equals 7 times sine 45 over 7 root 2. Now, you can either plug this into a calculator, or if you look at your unit circle, the sine of 45 degrees is root 2 over 2. So what I did here was notice these 7's cancel. So I have root 2 over 2, and then this is 1 over root 2 from these canceling. There's a 1 left. Otherwise, plug it into a calculator. But notice here that when you multiply these cancel, and it's 1/2. So the sine of B is equal to 1/2. Well, if I go back up here to this scenario, it says if the sine is less than 1, then I have to set up two triangles. And so because this is less than 1, I have to set up two triangles. And these are the two triangles. So it's kind of crazy here. So let me try to help you out here. So notice all I did was copied this triangle over here. So the sine of B is equal to 1/2. If I go to my unit circle, the unit circle has the sine equaling 1/2 at these two angles. So pause the video, look at that. It has it at 30 degrees and 150 degrees. So I have to set it up. I have to set this triangle up as this angle is 30 degrees, that angle is 150. Because I don't know which one it is because the sine is equal to 1/2 in two scenarios. So here what I'm doing is I'm trying to find angle C. 45 plus 30 is 75. Triangle adds up to 180. So I have 180 minus 75. That's equaling 105. Here, what's 45 plus 150? It's 195. Well, that's larger than 180. So this triangle doesn't work. So that we can get rid of, and we're going to just solve this now. And once again, it says solve triangle ABC. So I'm looking for 3 sides and 3 angles. So I now have the 3 angles, and I'm missing 1 side. So I'm going to use the law of sines to find that missing side. So I have the sine of B and sine of C. That's the one I chose. Plugging in that information, B is 30 degrees. Little b is 7 from being across. Sine of 105 and little c. When I cross multiply, I get this. And then I go from here and get that. Okay. Like I said, I'm going to try to post this on the internet. So hopefully I can post it. What I'm going to do is I'm going to pause the video. I'm going to make a separate video, so hopefully it's short enough. And this will be for this case. So look for part 2 of the 6.4 video.